Hello everyone, this is my first video on this YouTube channel. Today we will speak about Sentry, how it works, about Sentry architecture, how to install Sentry in your Kubernetes cluster using Helm, and also how to configure it properly in most efficient way. I will give you some useful advices that will save you time, so let's begin. Sentry is a software for monitoring the experience users get from your application. Doesn't matter what it is, if it's backend, frontend or mobile applications, Sentry covers all these things. In a nutshell, Sentry is a very handy thing that will allow your development team to handle different errors as soon as they are detected. So you decide what you log, what you trace and how you do it. As operations engineers, we need to have an understanding of how data is exchanged within Sentry, so we need to pay close attention to the architecture section. So let's take a look at the Sentry documentation. Here we have high-level overview. So we see that we have our application with Sentry SDK. Our application sends events to the load balancer, and after our event goes to the relay. Relay is responsible for routing your events to the different places, and also relay is responsible to check if there any project in Sentry associated with this event. So after relay, your event goes to the Kafka for processing by consumers. We will speak about it later. But also relay is caching events in Redis. And also we need to pay attention to the Snuba component. Snuba component is responsible for processing events and store it in the ClickHouse. For example, you will go to the Sentry dashboard. You will see a lot of metrics, a lot of data, and all this data are stored in ClickHouse. Based on this diagram, we can conclude we will have possibly two bottlenecks. It is Kafka and ClickHouse. In most of cases with Kafka it will be consumer log, and with ClickHouse it will be run out of disk space. Here we see more detailed diagram of our event journey. We see that raw event data goes to relay, and after this relay publish it to ingest events topic in Kafka. After this, these events are consumed by ingest consumer, and ingest consumer starts different tasks for preprocessing this event, like symbolicator or other things, or if you have different plugins enabled in your Sentry, this processing also will be in this section. We need to pay attention to this task save event. So here we see that save event task store our data in 3 different places. It is Google Bigtable, but as I said before, Google Bigtable are not used in Sentry on-premise version. Also it saves data to PostgreSQL database. I don't think that is true. Maybe this diagram is legacy. In the past, in previous versions of Sentry, all node store data was stored in PostgreSQL table called node store, and there was a problem when node store table was grown up until your disk ran out of space. Right now, this problem are fixed in newer versions of Sentry, so I don't think that it's true, because I read a lot of topics in Sentry forum, and developers said that they try to migrate from PostgreSQL to ClickHouse to store all events in ClickHouse and don't store any information in PostgreSQL. As I know, only information that are stored in PostgreSQL, it is only things like login, password, different settings in your dashboards. In a nutshell, all data that are associated with the user who use Sentry. So and here we see that task save event publish data to events topic, and this data are consumed by Snuba consumer, and after processing in Snuba, this data goes to the ClickHouse. For example, if you go to the Sentry dashboard and see different metrics, events, transactions, all this data are taken from ClickHouse. Also pay attention to this section. This section is responsible for alerts. If there are any problems with your alerts, maybe your reason hidden there. So let's make a summary. In my opinion and on my experience, in most of cases you will have problems with the Kafka and ClickHouse disk space. You need to correctly configure your log rotation in Kafka. You need to horizontally scale your Snowball consumers and Kafka topics, but we will speak about it later. Let's take a look at the Sentry Helm chart that we will use for our Sentry deployment. Here we need to look at the default values.yaml. I will show you some things that you will need to edit for better performance. Here we have relay. As I said before, relay is responsible for routing your events or transactions to the projects in Sentry. So if you have problems that some of your transactions or events are lost, or you have a delay but you don't have any consumer lock in your Kafka, or all other things are fine in your Sentry instance, you need to take a look at the relay. Maybe if you increase replicas of relay, throughput of relay will be increased and your problem disappear. Here we have worker. As I said before, if you have different problems with delay or transactions lost in your Sentry instance, you also need to look at the worker section. Here you can increase number of replicas for worker, and don't forget about these sections. You should to increase worker events if you have problems only with events. So like this, if you have problems with transactions, just increase worker transactions count or just enable it. Here we have configuration for our consumers. For example, you have Kafka topics and you have Kafka consumer groups. So your consumer groups associated with the Kafka topics that they are consumed. If you have any problems, shell to the Kafka pod in the cluster describe topic information to see consumer log. For example, you have a consumer log on events topic. You need to figure out which consumer group associated with this topic. You have consumer log on events topic, and consumer group, for example, will be ingest consumer events. So you need to scale up your topics count, for example, to 10 partitions, and also you need to scale up your ingest consumer events replicas to 10. Number of Kafka topics partitions should be equal number of consumers in your cluster. Here we have also a possibility of bottleneck. If you have a lot of events or transactions, just scale up your API. You can make a decision what you need to scale up based on CPU usage of API pod in the cluster. So let's take a look at our values that we will use for our Sentry deployment. Our override values.yaml. Firstly, we need to take a look at the user section. This section is responsible for user creation in your Sentry dashboard, so it's clear. Let's go next. Also, you can specify mail options for alerts or something like this. I will not configure it because it is only for educational purpose. So we define our ingress rules for Sentry instance. Make sure that you specified ingress class name of your ingress controller. So I use default ingress class name and Nginx. Use it for external load balancing. So if you have more than one ingress class name in your cluster, just change this value based on your ingress class name that you want to use for routing traffic to Sentry instance. Next, there is a cert manager annotations. It is necessary for creating a certificate from Let's Encrypt. Next options are clear, I think. Here we have external PostgreSQL. If you want to use external PostgreSQL, maybe in the cloud or on another node, just specify your Postgre cluster here and you need to change this value to false. In this situation, external PostgreSQL will work, but if you have enabled true, you need to specify size of your persistence because default values are very small, 30 gigabytes or something like this. Here we have RabbitMQ. RabbitMQ are used by default out of the box. I want to use Redis, so I changed value of RabbitMQ to false. I'm more familiar with the Redis. Very important section. You need to increase your hooks active deadline seconds because by default it is very small in most of cases. Your hooks like database initialization when installing Sentry or Kafka provisioning will fail because of a very small value. I increased it to 10,000. Kafka section also very important for us. Here I specify extra config for log retention milliseconds. It is about 10 minutes. By default this value 1068 hours. It is equal 1 week, so I don't need to store any logs in Kafka for a long time, so I specified log retention for 10 minutes. If you do not specify it, it is very high chance that your your disks will run out of space. Specify number of replica counts for Kafka controllers. By default it's 3, but I also specified for more clear vision to my videos. By default, out of the box subchart of Kafka, define very low requests and limits for Kafka pods, so you need to increase it based on your node's capability and other things like that. Also you need to define, just don't forget about size, make some experiments to define more efficient size for your Kafka controllers. Here I define storage class, it is necessary for my cloud provider. In your case it will be different. Let's go forward. Here we have Zookeeper. Do not forget about specifying size of persistence, because out of the box there is only 8 gigabytes. In the future persistent volume claims with 8 gigabytes will run out of space, so please define it here also, like size as I said before. Zookeeper is used for ClickHouse. ClickHouse also enabled here. It is very important to specify size of persistence for ClickHouse, because all your events transactions are stored here, and default data rotation in ClickHouse are 90 days. Maybe default values of ClickHouse persistence will not be enough for you. Also, if you want to use external ClickHouse, just turn Zookeeper enable to false and ClickHouse enable to false, so this section will work. In this case, doesn't matter what you specify here, this section are not used because ClickHouse enabled and Zookeeper enabled. Here we enabled Redis because it is disabled by default. Out of the box there is a RabbitMQ instead Redis, so I decided to use Redis instead RabbitMQ. In my experience, default values of persistent volume claim for Redis enough, and I didn't change it. So if you want to use external Redis for your Sentry instance, just disable Redis here and specify values for external Redis and you will be fine. And also I specified Sentry cleanup policy for 30 days instead 90 days. So let's save it. After that we need to add Sentry Helm chart to our Helm repo and finally install it. In my case, default timeout that equal 5 minutes is not enough for installation, so just increase timeout to 50 or 20 minutes. Documentation says that you need to specify also wait flag, but if you specify this flag there will be a problems when you will deploy this Sentry chart, because sometimes this chart have an error, so remove this flag and install Sentry. Let's move to our Kubernetes cluster, and here we see that installation process. So right now we just need to wait until all pods will be healthy. If you will specify wait flag, as I said before, there will be a problem that your Nginx pod will not be healthy, because Nginx pod have dependence with the relay and Sentry web pod. So as we can see, Sentry web pod are not healthy. Sentry web doesn't see any relations in our PostgreSQL database. After a while, database initialization jobs will be started. So after Kafka provisioning, after this job, there will be another jobs that will migrate all data that are needed for Sentry. As we can see here, Kafka provisioning our topics to our Kafka controllers. After this, there will be Snuba migrate job that will migrate all tables to the ClickHouse, and after this there will be Sentry migrate job that will migrate all tables to the PostgreSQL, and only after this our Nginx pod will be healthy. If you set wait flag in Helm install command, there will be a problem that database initialization and migration jobs will not be started because Nginx pod is not healthy. You need to remember this. As we can see, provisioning succeed. So right now there will be another jobs like Snuba, DB and net. So this job is responsible for adding different topic and checking it, and after there is another job that is responsible for ClickHouse migrations. So as we can see, our migrations are running now, so we need to wait. Sentry DB is responsible for migrations in PostgreSQL. So we can see that our migrations are applying now. So our migrations are done. So right right now there is starting Sentry user create pod that are responsible for user creation that we specified in our values.yaml. And after user creation different consumers are being deployed in our cluster. So as you can see, there is very high memory level, so before installing you need to have a very good cluster with enough memory for deployment. Right now I have about 5 machines with 4 GB of RAM. So as we can see, our chart successfully deployed. We can dive in our cluster and see that Nginx pod are healthy. Now we can log in our Sentry dashboard based on our ingress address that we specified. Example metops.ru and password. Not now. So here we just need to specify few radios and hit continue. So as we can see, Sentry has been successfully installed. Right now we can add different projects in our Sentry based on your stack, like Node.js or iOS, Android and other. So thank you very much for viewing. I hope this video will help you for setting up your Sentry. I will add some links in the description to the issues on GitHub where is problem with Kafka topics and consumer replicas are described more detailed. So if you will need to configure your Kafka topics to increase throughput of Kafka, just dive in the description and find all answers that you need.